Now let's begin our discussion of angles. Found this little graphic off the internet. You might have heard of these terms. These are angles which aviation officials need to know. If you're a pilot, you need to know what the yaw angle is, the roll, and the pitch, okay? Now, I just thought it'd be an interesting graphic, okay? So let's start talking about the angles. We know we're going to talk about how we classify angles. Angles, okay, are by definition two rays with a common endpoint. That endpoint is called the vertex. In this picture here, the rays are not actually shown as rays because rays actually continue onward and onward. So I could put arrowheads on there to be a little bit more official with the definition, but most people will pretty much draw an angle this way. I'm not going to make a big deal, but officially it's two rays with a common endpoint. Okay, how do we name an angle? Well, okay, in this particular case, we have a couple different ways. Let's talk about it. Angles are named for the 3 points of the two rays where the vertex point is in the middle. So this angle is angle A, B, C. Most likely whenever we name an angle, we're tracing it out. A, B, C. The vertex is always the middle letter. Okay? I could have alternately named this angle CBA because again, the vertex would still be in the middle. I could have referred to this angle as B, angle B, because really there's no other angle here, so there's no confusion about it. So that's naming it with the vertex. Or I could refer to it, just call it angle 1, all right? In any instance, all these are 4 different ways of naming that angle. The angle is measured in degrees. In this case, Sketchpad measured it with 49.06 degrees, okay? I rounded it off down here, not a big deal. Later in trigonometry, in Algebra 2, the angles will be measured in radians. It's nice if you can eyeball an estimate of the size of the angle. An angle 90 degrees, angle formed by the hands of the clock at 3 o'clock, quarter after 12, okay? 60 degrees, okay? 2/3 the size of that, that's the opening. This is the angle. The angle is the sweep inside of the two rays, a 45 and a 30. Some interesting ways of measuring an angle using your fingers and thumb. If you outstretch your hand in this fashion at arm's length, just hold it out to you like that, okay? And the angle that's formed as the light passes back to your eyeball is a 20-degree angle. Hold up your thumb at arm's length. The angle formed by the light rays coming back to your eye from the tips of your thumb is a 1-degree angle. In the night sky, if you hold your thumb up, you can pretty much block out the whole moon, which is to say that the moon is subtending an angle of 1 degree to your eye. And likewise, why we sometimes have eclipses is because either the moon passes in front of the sun or the sun passes in front of the moon, because likewise you could block out the sun with your thumb held at arm's length, okay, so that the sun rays coming back to your eyeball form a 1-degree angle. Just some interesting thoughts I thought you might like to see, okay? All right, we know the different types of angles. Right angle, 90 degrees. Usually a box is put in here, then we know it's a right angle, okay? Obtuse, greater than 90 but less than 180. Acute, less than 90. And a straight angle is, of course, a 180-degree angle, but, okay, we might call that opposite rays, or you might call it a line. So, 2 definitions for a straight angle, opposite rays, or a line. Okay? Now, much like um, much like we had for segments, we have what we call the angle addition postulate. If we look at the overall angle, angle A, B, C, and we pick any point on the inside, point D, imagine that the ray here wasn't here. Any point on the inside, okay, we can form a ray from point B to D, and now form two additional angles. Okay, so the two additional angles that we form, mainly angle ABD and angle BDC, are what we call adjacent angles. And it's pretty intuitive that the sum of angle ABD, and I stand corrected over here, so you want to read that as angle ABD, that's just a typo, plus angle DBC is equal to ABC. So the sum of the two angles inside here equal the third, okay? So that's exactly what this is saying down here. And we're going to reference that to some algebra problems of sort, all right? So in here, as you can see, the measure of angle AOB plus the measure of angle BOC is equal to the all-inclusive angle AOC. So let's throw some values out at you, okay? Angle AOC, the biggest all-inclusive angle, this sweep here is 120 degrees. Angle BOC, this sweep here is 75. We're asked to find what is the measure of angle AOB. So we simply write the postulate, angle addition postulate, the sum of the angle AOB, which is unknown, plus the known value of 75 here gives me 120. Little algebra, subtract this 75, and we have the measure of the missing angle is 45 degrees, okay? A couple more. Pretty much you can just look at these here, okay? In this picture, the largest angle, the angle indicated, the angle GAB, indicated by this sweep here, this arc sweep of 64, okay? That means that the all-inclusive angle is 64. We're obviously trying to find CAB, okay? So that would simply be the difference between those two, accounting for an 11-degree angle at CAB. Likewise here, the 153 is indicating the largest angle, the angle MLP. The one angle of PLN is 95. Their difference, 153 minus 95, being 58, would be the measure of angle MLN. Now let's look at these, which are a little bit more algebraic, okay? These values up here mean nothing, okay, so we'll just ignore them. Here's much like what we did with the angle addition, we now do with the, much like we did with the segment addition, we do here with the angle addition, okay? We have this figure. In this figure, angle 1 is 8x minus 6, so I just put that right in there. Angle BAD, that's one bad angle, okay? That bad angle has 20 degrees as its measure. The other angle, angle 2, is 2x plus 1, okay? So from the angle addition, angle 1 plus angle 2 is equal to the one bad angle, that's 8x minus 6 plus 2x plus 11 equals 20. Now it's just all it is a algebraic equation now. So we connect our like terms. 8x and 2x is 10x. Negative 6 and 11 is 5. So we get 10x plus 5 is 20. Subtract 5 off of both sides. X is 1.5. The question was, what is the measure of angle 2? Over here it told me angle 2 is 2x plus 11. Well, now that I know what x is, mainly 1.5, I'll come down here. 2x plus 11 is 2 times 1.5 plus 11. 2 times 1.5 is 3 plus 11 is 14. Similar problem down here, number 23. Okay? Again, the problem would give you this bit of information and the angle, okay? So from, again, the big angle BAD is now expressed as, sorry about that, okay? The big angle BAD is now expressed as 11x minus 6. The angle 1 is expressed as 5x plus 6. The angle 2 is expressed as 3x plus 9. Again, angle addition postulate says angle 1 plus angle 2 is equal to angle BAD. Therefore, 5x plus 6 plus 3x plus 9 is equal to 11x minus 6. On the one side of the equation, you add up your like terms, 5x and 3x, 8x. There we go again, I apologize. It's a little sensitive, okay? We'll come back to that. Okay, again, what we're dealing with here now, 5x plus 6 plus 3x plus 9 equals 11x minus 6. Okay, at this stage, we connected our like terms, okay? Subtract 8x off of both sides, that gives you 3x. Add 6, okay, to 15 gives you 21. X is equal to 7. We got to go back and see what it was we were after. We were trying to find the measure of angle 1. Angle 1 is 5x plus 6. With the value of 7 thrown in for x now, we get 5 times 7, 35, plus 6 is 41. Okay, so the angle 1 is 41. And that's all that we were asked to solve. So now that's the angle addition postulate. You should be able to